Good morning, everyone.
Good morning, sir.
Good morning,
Good
sir.
morning, sir. Good morning. Good morning. Is it visible?
Yes, sir.
Yes, sir.
Okay, thank you. So last day I have discussed about the architecture of 8085 microprocessor. Now today that is the most important topic, that is 8085 instruction set. Uh, so I'd like to discuss the different instructions, what is the function and how the instructions are classified, what are the different addressing modes are available so that you can use them according to the rules. Um, so these topics will be covered today. So basically every microprocessor has its own instruction set. Okay, suppose different manufacturers has different manufacturing IC, 8085 IC for individually. Like Intel, it has microprocessor IC, Motorola has microprocessor IC, Texas Instruments, Zilog. So for every microprocessor there is a particular instruction set which is designed by the particular manufacturer of that IC. So based on the design of the ALU and the decoding unit, microprocessor manufacturers basically mm, uh, they generally list out the instructions for every microprocessor they have designed, they have manufactured, and the instruction set, which is the combinations of the mnemonics and the machine code, corresponding machine code. Okay, so the purpose of the instruction set is to facilitate the development of efficient programs by user or by programmer. And this instruction set, it is based on the architecture of the processor. All of you know about the architecture, how many registers are available, how they can be used, what are the functions, the working principle, everything. All of you are familiar with this architecture of 8085. So to understand the instruction set of a processor, it is necessary to understand the basic architecture of the microprocessor and the user accessible registers in it. Means which uh, registers are which registers can be used for your programming purpose, to write your instructions, to write the logic of your program. Okay, so you must familiar with the registers. And so what is the instruction is a bit pattern that is decoded inside a microprocessor to perform a specific function. I repeat, instruction, which is a bit pattern that is decoded inside a microprocessor to perform a specific function. Okay, and the program, which is called basically assembly language program. Okay, and this assembly language mnemonics are the codes for these binary patterns, so that the user can easily understand the functions performed by these instructions. The entire group of instructions that a microprocessor can handle, that is called a instruction set, and this determines the microprocessor's functionality. So the Intel 8085 processor, it has own set of instruction listed both in mnemonics and machine code, and that is also called an object code. So as the 8085 is an 8-bit processor, the machine codes for the instructions are also 8 bits wide. Okay, remember this. So now classification of instructions, how instructions are classified based on um, actually the 8085 microprocessor instructions can be classified based on parameters such as functionality, length, and operand addressing. Okay, functionality, length, and operand addressing. Operand means the data by which that particular operation can be performed. Okay, so every instruction has two parts: opcode and operand. Opcode and operand. Opcode means operation code, which operation is to be performed, like add, sub, and, or, XOR, uh, compare, CMP. So all these are MVI, move. So all these are opcode. Now by which that operation can be performed is called the operator, the data part. Okay, so instruction classification, based on the functionality, there are 5 categories. Number one, that is data transfer or data copy instruction or data copy operations. Okay, number two, arithmetic operations. Number three, logical operations. Four is the branching operation, and the last is the machine control operations. Okay, so first one is data transfer or data copy operations. So this group of instructions, that is, these instructions copies the data from one location, from a location called source register, to another location which is called as destination register. Generally, the contents of the source registers are not modified. Although the term data transfer is used for the copy operation, it is somehow confused because it implies that the contents of the source memory location are destroyed. No, it will be not modified, it will be remain same, just it is copied from one position to another position, just like you have done in your PC, the copy paste operation. Okay, so you need to copy something and paste it in somewhere else. That doesn't mean that where from you copied that particular content is modified or altered. No, it will be remain same as it is. Only the difference is it will be copied into new location. Okay, so that concept is implemented here. So there are different types of data transfer instructions, like move instruction, MOV, MVI instructions. Um, One group has already performed the program in lab class using MVI instruction. So move, MOV, MVI related instruction, LXI related instruction, LDA, STA. So all these are data transfer operation instruction. Okay. So now from this list, this table, you can say that MVIR, R means register. It's a syntax. Okay, syntax means used to uh, identify this one, but you have to write it in this way. This is the actual uh, instruction. Okay, just to understand the function, I have written R, RP, RD, RS. These are the notations used to understand the particular instruction. Okay, but actual writing way or method is, these are the actual instructions. Okay, you need to write it in this way. So MVI, R means the register, any register. Which registers? Those are programmable. Those are uh, those can be accessible by the user or programmer. Okay, now how many registers are available? Programmable registers, 7 programmable registers are available. A, register B, register C, D, E, H, L. Clear? Only 7 programmable registers are available by which you can write your instructions. So MVIR, any register, comma, 8-bit number, any number, any 8-bit number in hexadecimal. Okay, so what will be the range of that data, 8-bit data? It is from 00 to FF, 00 to FF. So how many data are there? 256 256 data are available. Okay, so you can load any number, any data from 00H to FFH, any number into the any 7 programmable register, any one among the 7 programmable registers, just like it is written as MVIB comma 3FH. Okay, MVIB comma 3FH, that means load register B with the data 3F. Okay, one second, call. Okay, hello, I'm audible, am I audible?
Yes,
Yes,
sir.
sir.
Okay,
Yes, sir.
so the thing is MVIB comma 3FH, the meaning of this one is load the register B with the data 3F. Okay, so it is basically storing a data byte in a register. It is a so it is used basically to store some data byte into a register, any register among 7 programmable registers. Okay, you can write it as MBI A comma 3F also if you want to load some data byte into accumulator. If you want to write it MBI C comma 3F, MBI D comma 3F. So I, if there is an I, that means there must be some data. If it is I related instruction, that means there must be some data. So this is your data, 8 bit of data, 3F, which is 8 bit in size. Okay, another is the move instruction. Another is the move instruction. This is also move instruction, this is also move instruction, but the difference is it is used for 8-bit data purpose, and this one is used to register operation indirectly. But indirectly means if you want to transfer some data byte from one register to another register, then you need to use this kind of instruction, like it is written as move A comma B. That means move the or copies the content of register B to the accumulator, register B to the accumulator. So always the first thing, first register which is written in any instruction, that will be your destination. But here this one B, This is your destination path where it will be stored. It will be stored in B. In this way, the content of B will be stored inside A register. So this is used to store a particular number into a register, and this is used to store the number which is stored inside another register. So it is register to register operation. It is immediate data to register operation. That's why I is related to this one, and this differentiates the mm, instruction. It is MOV. If any instruction is related MOV, that means the it is related to the register to register operation. But if there is an instruction called MVI, that means there must be some data byte which will be loaded in some register. Okay, here you know the definite data, but here you don't know the actual data. Whatever be your data, that will be moved. Okay, next is LXI. Okay, I will discuss it later. LDA, LDA or STA. Last day, those who have performed the lab, they are familiar with this term STA, any 16-bit address. That means store accumulator direct to the memory location. Store accumulator direct into the memory location. So this is basically transferring the data between memory and a register. Okay, memory and register. So STA, you can write it as STA 9050. So what is 9050? 9050 is a one memory location where you need to store the data from accumulator. So storing means from accumulator to the memory location. Storing means from internal to the external. Do you have pen and paper with you? If you have, then you can write it. It is very important to write it, or you can remember it. uh, Storing means store means from internal to external. Store means st means store, and ld means load. So store means from internal to external, and ld means load means from external to internal. Got it? Shall I repeat it again?
Yes, sir. Once more.
So STA means store. So ST means store. Any instruction related to ST means store. Store means from internal to external. Transfer of data from internal to external. Store means from internal to external. Now why it is so called internal to external? Because A, B, C, D, all these are registers. So where these registers is, it is inside the processor. It is internally situated. What is external? Memory is external. So if you want to transfer a data byte from any register to memory location, that means data must be transferred from internal to external, and that data transfer is called the storing operation. And just opposite to this one, from external to internal. Now, which one is external? Memory is external. So from any data byte that you want to transfer it from memory location to any register, means from external to internal. That is called load operation. LD means load operation. From external to internal, from memory location to register. Okay, so one thing you have to notice it here, that this one is only applicable with accumulator. You can't write LDB or LDC or STB, STC, STD. No, only A is involved to operate this kind of operation. Why? Because all the operations are accumulator oriented operation. So accumulator is the gateway to perform any internal to external or external to internal data transfer operation. Okay, so you can't store it in anywhere else except this accumulator. So this store and load related instruction STA LDA, that is applicable with only accumulator. Okay, so only STA is available. There will be no STB, STC, STD, STH, STL, STE, no, nothing. Only STA is available, only LDA is available. So this is a one kind of data transfer instruction from internal to external or external to internal. LXI. Now LXI, coming to this instruction, LXI RP means register pair, comma 16-bit data. 16-bit data. Okay, now how many register pairs are available? 3 register pairs are available. What are they? BC register pair, D register pair, and HL register pair. So you have to write it in this way, like LXI B, comma LXI B. So B means BC register pair. You can write it as LXI D also. That means D register pair is involved. You can write it as LXI H also. That means HL register pair is involved. Okay, so you have to specify only the higher byte of that register pair. Okay, B is the higher byte as C is the lower byte. D is the higher byte, E is the lower byte. H is the higher byte, L is the lower byte. So LX only you need to specify B. Don't write it as BC. Okay, B represents BC register pair. D represents D register pair. Only one register has to be specified into your instruction. So LXI B comma 5AF3. What is that? This is 16-bit data. This is 8-bit data. This is 16-bit data. Can we identify both of them? Which one is 8-bit, which one is 16-bit? This is 8-bit data. This is 16-bit data. 5AF3. Okay, so if it is used BC register pair, okay, 1 minute, I have to use paint. So I can write it as LXI suppose V comma 1 2 3 4 H. So LXI B comma 1 2 3 4 H. So that means so there are two registers are involved. Two registers are involved. One is B, another is C. Suppose this one is your B and this one is your C register. So I have 16-bit number 1 2 3 4. So 3 4 will be loaded into C register if this instruction is used. Then 1 2 will be loaded B register, so that by the combinations of this BC register pair we can hold it as 16-bit number 1 2 3 4. Clear? So lower order 8-bit will be stored in lower order register and upper 8-bit will be stored in higher register. So the meaning of LXI B comma 1 2 3 4 is load L means load extended data, immediate data. Is it visible, this paint screen?
Yes, sir.
Yes,
So
sir.
L means load, X means extended, I means immediate data. Now what is the difference between this one and this one? MVI B comma 1. Can you identify what is the difference? MVI, this is used only with 8-bit number to load any 8-bit number into any register. LXI B, 1234, that is used for 16-bit number storage purpose. If you want to store some 16-bit number, any 16-bit number, you can use register pair. So MVI, that is used for 8-bit purpose operation. LXI, that is used for 16-bit purpose operation. The full form of LXI is load the extended, I means immediate data into register pair. Extended immediate means more than 8-bit. Okay, according to this name XI, the meaning of this one, extended immediate data. Extend version means more than 8-bit. Normally it's an 8-bit processor. Okay, so every operation is based on the 8-bit data, but if it is extended, that means more than 8-bit is involved in this particular operation. That is the difference between MVI and LXI. Okay, so if you want to store any 8-bit of data, you have to use MVI related instruction. If you want to store any 16-bit of data, then you have to store it using LXI related instruction. Here you can use all 7 programmable registers. Here you can use only 3 register pairs. Is it clear? Any confusion up to this one? If you have, then ask me now, because this is very, very important. All these instructions are these will be used every day in your lab class. So these are very important instruction. You have to clear this concept. If you have any confusion, you can ask me.
স্যার একসঙ্গে
হুম।
স্যার একসঙ্গে 8-bit আর 16-bit ডেটা দুটো একসঙ্গে মানে আমি এ করতে পারি কি এক্সিকিউট করতে পারি?
একবারে কি করে পারবে? একটা ওয়ান টাইম একটাই তো কাজ করতে পারবে।
হ্যাঁ, ওয়ান টাইমে আমি 16-bit দিলাম, এবার পরের
দিলে।
ইনস্ট্রাকশনে সেখানে আমি 8-bit দিলাম, সেটা
হ্যাঁ, দিতেই পারো।
available হতে
ওভাররাইট
পারে।
হয়ে যাবে। ক্লিয়ার? আমি ধরো প্রথমে লিখলাম LXI B, 1234, তার পরের লাইনে আমি লিখলাম MVI B, 56. Then after executing this instruction, this one will be cleared. Okay, this one will be changed as 56. Clear? Because it is overwritten.
ওকে ওকে।
Anyone else? Any queries?
No, sir.
Okay, I don't need to discuss this LHLD, SHLD, push pop right now, because these are not used very much in your program. Okay. Another is the in instruction. In instruction. In instruction, that is used for input data which will be loaded inside accumulator. Okay, input data means if any input device is connected, suppose one switch is connected with the microprocessor IC, then according to the switch position, whether it is on or off, on means 1, off means 0. Okay, so this status will be transferred into the accumulator. If you press the switch for on purpose, so 1 will be stored into the accumulator. So how this will be stored? That's why this in instruction can be used to process your data. So it will send the data from the device to the accumulator, sends the status of your input device to the accumulator, and it is given that in 8-bit, 8-bit is the address, port address. Okay, memory address is always 16-bit, port address may be 8-bit, maybe 16-bit. It depends on the method, either it is memory mapped IO or IO mapped IO. Okay, so that is the different chapter. Right now you have to understand that if in and out instruction is in, it is used for input purpose, out instruction will be used for output purpose. Okay, but both are applicable with accumulator only. In means it will be transferred the status from this port address to the accumulator if it is written as out 40, out 40 means the accumulator content will be transferred to the port address 40 where some output device is connected. Suppose one displays there, LED displays there. Okay, so that will be displayed on the screen. Okay, in and out both are applicable with accumulator because both are used to process the external and internal data. Because input and output device must be connected. These are external to the processor. It is outside of the processor. So if you want to transfer the content from input device to the accumulator or any register, there must be accumulator must be involved. Okay, because accumulator is the gateway, I have told you earlier, to transfer the content from any external to internal or from any internal to external operation. Clear?
So,
Hmm.
so
Yes.
that means
Hmm.
if we use this in operation
Hmm.
and write IN30H, that means if in case the pin results in true, that is the pin is active, then it will result the value 30H in
pin?
the accumulator.
Which pin?
Then sir, from where it is taking the data?
Yes, yes. Suppose in 30, this address, because microprocessor don't know what is switch, what is keyboard, what is mouse, what are the different input devices. Okay, so every device must be identified by some address. So each device has its unique address. Huh? Is it clear? Microprocessor doesn't identify which one is RAM, which one is ROM. It is only identified by some memory location. In the same way, every input and output devices, those are connected with any microprocessor based system, microprocessor can understand only the address. Okay, either it can send the data to that particular address or it can receive the data from that particular address. So here 30 is the address, port address of the input device. So if it is connected to any input device, the status of that input device will be loaded inside accumulator. Is it clear?
Sir, status. So what is significant by status?
Status means if it is suppose any digital system. Okay, assume
Yes, sir.
any switch is connected. Just I have told you earlier. If you want to connect one light and one fan with the microprocessor, then that fan or light must be controlled by some switch. So you have to connect switch also. So here switches are used as your input device, and light and fan, these are output device. Clear? So when you press the switch on, at that time light will be on. For fan, if you switch on, the fan will be on. If you press the switch, so what is the status of your switch position? Digitally either 1 or 0. If you press the on switch, that means 1, logic 1 is transferred. If you off the switch, that means logic 0 will be transferred. Is it clear? So microprocessor has to
So
identify
that means,
uh,
so that
yes,
means in this in operation, sir, we are specifying the address of that device which is
obviously
connected with the microphone.
address is to be defined. Address must be defined,
Okay.
because without knowing the address, how the microprocessor can read the data? Clear?
And
It's
sir,
just
the
like
only values that can be put inside the accumulator is 1 or 0
just
in
as
this
for
in and
example,
out operation.
as for example, what will be the status of your input device? That must be transferred to the accumulator. I have just given an example, short example. Okay, simple
Okay.
example I have given, that if you want to connect any switch and light, if you press the switch on, then light will be on. If you press the switch as off position, so light will be off. It's I have given one example, simple example. Okay, so that status should be stored inside the accumulator, and according to the status, the output will be transferred. ক্লিয়ার? কারণ মাইক্রোপ্রসেসর বুঝতে পারবে না কখন তুমি সুইচ অন করছো বা অফ করছো। হ্যাঁ, microprocessor can't recognize what
Yes,
is
sir.
don't know about switch. Okay, it's just receive the data. It's receive the data.
Sir, a slight verification. That means this 30H is the address of that
address
port.
of that device. Suppose in 30 I have connected one switch, and out 40 I have connected light. Okay, so microprocessor receives the status from the 30 whether it is 1 or 0, and according to that it will be processed to the output device. Light will be on or off. Clear? Suppose in 31 is there, and in 31, suppose 31, in this address I have attached a keyboard, and out 41 I have attached one output device, like one printer is connected. Okay, so when I
Yes.
press some key on this keyboard, so that key should be identified by the microprocessor, and that switch position or switch status must be given to the processor. Inside, it goes to the inside of this processor, and in this way it manipulates the operation and send the output signal to that printer that you have to print that particular key. Suppose I have pressed A on my keyboard, which is connected into this address 31. So that A is processed and it will give to the output address 41, so that it prints the switch A. Clear?
Yes,
So for
sir.
every input
Now
and
it's
output devices, input output devices are connected in this way using the port address, and it is identified by the port addresses. Clear? Any confusion?
Yes. No, sir. Thank you, sir.
Anyone else?
স্যার
Yes.
স্যার বলছি ইনস্ট্রাকশন পারপাস না, বলছি স্যার পিন ডায়াগ্রামের কোন পোর্শনটা স্যার আমরা ইউজ করতে পারি না বা ইউজ করা হয় না, মানে কন্ট্রোলের ক্ষেত্রে, যে কোনো কন্ট্রোলের ক্ষেত্রে?
তুমি মাইক্রোপ্রসেসর ইউজ করলে তোমার পিন তো লাগবেই, সবগুলো পিন, অল
মানে
দিস আর
একটা পিন আছে না যেটা যে
কিটা?
ওই পিনটা ওই 0 0 1 টু 0 15 পর্যন্ত, ওটা হচ্ছে গিয়ে কোনো একটা হায়ার অর্ডার লোয়ার অর্ডার এরকম সামথিং কিছু একটা
অ্যাড্রেস
ব্যাপার ছিল
তুমি
না?
বলো, তুমি যদি ফ্লিপকার্ট থেকে কোনো কিছু অর্ডার করো, হ্যাঁ, অনলাইনে কিছু অর্ডার করছো, তোমার কোন জিনিসটা সব থেকে জরুরি? তোমার জিনিসটা
স্যার
পাওয়ার
আগে
জন্য, তোমার জিনিসটা
হ্যাঁ হ্যাঁ
পাওয়ার জন্য কোন জিনিসটা জরুরি, যেটা দিতে হবে ইনফরমেশন? অ্যাড্রেস।
স্যার অ্যাড্রেস।
অ্যাড্রেস তো তো তুমি যদি অ্যাড্রেস না দাও, তাহলে তুমি সেই জিনিসটা পাবে যেটা চাইছো, যেটা অর্ডার করছো? নট পসিবল।
না স্যার পাবো না।
হ্যাঁ, তো সেম কনসেপ্ট ইজ ইমপ্লিমেন্টেড হিয়ার। মাইক্রোপ্রসেসর যদি কোনো ডেটা কোনো জায়গা থেকে আনতে চায়, বা কোনো ডেটা যদি কোথাও পাঠাতে চায়, the main thing is to identify the address. It needs the address. Okay, for that purpose you need that AD0 to AD7 and A8 to A15 lines, because your 16-bit address will be transferred through these lines. AD0 to AD7 and A8 to A15, these are total 16 address lines which are required to process any data. So প্রথমে অ্যাড্রেসটা দরকার, এবং তারপরে যখন অ্যাড্রেস আইডেন্টিফাই হয়ে গেল, then it needs the data which can be fetched by the microprocessor, or that can be written into some memory location. Okay, so all pins are very important. All pins are used, not at the same time all pins are used, but these are used. Okay. Anyone else? Any queries?